Hello and welcome to the Cisco Security Channel. My name's Alex Kirk and I'm a consulting security engineer out of Atlanta, Georgia. I'm going to be talking to you today about firepower threat defense, specifically how to replace ACLs with fully qualified domain names from an ASA config with a Layer 7 app detector in FTD today. The concept we're talking about today is pretty simple. It's a network object that has a fully qualified domain name in it instead of an IP address. Now, of course, the system still has to resolve that fully qualified domain name down to an IP address for Layer 4 comparisons. But because that process is a network lookup with all the latency that involves, you obviously can't do that translation at runtime as you're attempting to compare packets coming across the wire to your ACL. So instead, that's something that's done on a periodic basis by the system. Doing those periodic lookups on the ASA worked pretty well, except for the time between a change in reality and the next resolution by the ASA. By default, that resolution was being done each time the TTL, or time to live, for the previous response expired. Since DNS TTLs in the wild typically range between 1 and 24 hours, that left the ASA with a potentially large window during which it would be out of sync with reality. While the obvious functional answer to this is to do lookups more frequently, there are limits to how often you can practically do those lookups, with everything from throttling by your DNS provider to the accumulated CPU cycles of comparing newly looked up IPs to those in the tables in memory starting to add up to a significant amount of processing power, especially on lower-end devices. So given the inherent unsolvability of that race condition, we at Cisco actually suggest solving the problem in a different way, through Layer 7 application detectors, which are built in as a fundamental part of what makes firepower threat defense a next-generation firewall. Those app detectors are matching strings directly within the relevant protocol requests, taking the need for translation completely out of the mix. Out of the box, Cisco supplies thousands of prepackaged application detectors, including many popular cloud applications that you might wish to control access to, like Office 365, Salesforce.com, Google, Facebook, etc. But it's surprisingly easy to create your own detectors for services that we as Cisco don't maintain. So first, let's talk about how to use built-in application detectors to control access to public services. We're in the access control policy of a firepower device, which is where you configure Layer 7 firewall rules. And those rules are built starting with this collection of tabs here on the left that are all the different ways that you can match a packet, whether that be zones that are groups of interfaces, traditional IPv4 networks or VLANs, or some of the more advanced work we want to do here today, such as Layer 7 application. So if we come and look at the available built-ins, we're going to see that there's a great deal of detectors pre-maintained by Cisco, and these actually get pretty granular in terms of not just am I blocking Google altogether or not, but do I want to allow the Google Analytics that are part of JavaScript coming down on your average web page, or do I want to get more granular and say that I want to block outbound Google APIs from my environment because that's a great way to exfiltrate data. And so really all you have to do is choose your application. Let's say it's Salesforce.com, as talked about earlier. You hit Add to Rule. You choose additional criteria that you might want to specify. For example, user integration using Cisco ICE would allow us to say, I want the sales organization to have access to Salesforce.com because I am allowing it in my action here, although I have the option to trust would be to fast path out without further detection, do additional logging, or block with or without a TCP reset or a custom HTML specified web page telling folks that they've been blocked. And in this case, since I'm allowing it, I have the option of applying a different IPS policy or a different anti-malware policy to that traffic specifically, so that I can have a different security posture for different types of traffic. Using application detectors to control access to services is a pretty easy process if it's built in, but what if you have a resource that isn't available within the system? As we can see here in the application detector policy window, we have a built-in create custom detector window where we would put in a name for our detector, and create an application protocol that we're going to be detecting. Here I'm using the same name as the application detector to make things simple and understandable for everyone involved. You have to select a business relevance and a risk level, and add a category here. Since we're doing something for the actual management console that we're using, we're going to choose network utilities here and click OK. And once that application shell is saved, we come back to the detector wrapper, and we're going to choose that from the list of application protocols in the drop-down box here, which populates right at the top with the application that we chose, and then come in to actually suggest a pattern for it. Now, the detection patterns are simple strings, although we have several different fields that we can look in for those strings. In this case, we want to talk about an SSL host specifically. We can also look for factors in the certificate like a common name or an organizational unit. And here we'll just go ahead and put the string of the device that we want to control access to. Before we finish creating our detector, we can see that Cisco recommends using a packet capture to test your custom detector and confirm that it works in your deployment. You can use any libpcap compatible tool you wish to capture those packets. For those who might be a little bit less familiar with doing so, Wireshark is an industry standard tool that is open source and available for a variety of operating systems that allows you to, with a very friendly user interface, capture packets off of your local machine. I always recommend using a filter whenever generating a packet capture for a purpose like this. Computers are surprisingly noisy on the network, and you really want to focus just on the packets that you care about. In this particular case, we can see that we're looking at the client hello packet, which specifies that we're talking to the server name that we entered in our application detector just a moment ago. If you want to build an application detector that doesn't use one of the built-in Layer 7 protocols that we dissect, such as HTTP, SSL, or SIP, in our example here, a FTP service being given off by a Rico multifunction printer that we've got captured already, you have the option of choosing TCP or UDP as your protocol, and then specifying whether you're entering a pattern in ASCII or hex, as the case may be, and putting in bytes that you expect to see directly within that packet. You've got an optional offset of bytes to skip into the packet before you begin to look for that string in case you expect it to be in a particular spot. And of course, you'll need to enter the port and the direction the packets are coming from, in this case from the FTP server. Once you've created your packet capture and uploaded it to the system, testing it against your new detector is as simple as hitting the test icon in the packet capture section of the screen here, and hopefully getting a service is detected message. If for whatever reason you don't detect the service, the first thing you should check if you're using Wireshark is whether or not you have incorrect TCP checksums. This is something that can happen due to the nature of the way TCP stacks are computed and captured on a given device. If you do run into something like this, there is a free open source tool called TCP Rewrite that is an easy way to fix your checksums and make the system work well with your packet captures. The final step in creating a custom application detector will be to come back out to Policies Application Detectors, find the detector that we've just created, and then use this state option here to enable the service. Now, this process is actually going to take a couple of minutes because it's pushing an updated policy with that new detector down to connected devices, which, if you're in a production environment, is something Cisco recommends doing only during an appropriate change window. Once your new detector is successfully enabled, you'll find that it's available for easy use back within the access control policy. That brings us to the end of our material today. Thank you for watching. If you have any feedback you'd like to provide, you can reach me at my work email or personal Twitter, as you see on the screen. Have a good day!